Kirchhoff's voltage law. It states that the algebraic sum of the voltage around a closed path or loop is equal to 0. And in this problem we're going to be solving for V1 and V2 by using KVL. Alright, as you can see, we have a 20 volt source in series with a 2 ohm resistor as well as a 8 ohm resistor. Alright, so the first thing I'm going to do is I'm going to draw my current in here. And this is the direction of the current, which I'm assuming based on the source. Okay. And through Ohm's law, we can see that V1 is equal to this I times the 2 ohms. Voltage is equal to I times R. And for V2, which this current comes through the negative side of this resistor, which was defined in the problem, so that's going to be a negative I times 8 ohms. Now back to KVL, and we have to add up all the voltages and set it equal to 0. So current, we're going to start right here. Current going into the negative side of the source, which is going to be negative 20 volts. Alright. Plus our V1 going through the positive terminal. And then minus V2, that's going through the negative. And set it equal to 0. Alright. So we can move this 20 to the other side. And we also can take this V1, plug it in there, V2, plug it in there, and that'll be I 2 ohms minus I 8 ohms, set it equal to 20 volts. We can factor out the I's of the current, which is going to be 2 ohms plus 8 ohms, which is equal to 20 volts. And 8 plus 2 is 10. So I times 10 ohms is equal to 20 volts. Alright, moving right along, we can solve for this I, continue to solve for this I, which I is going to be equal to 20 divided by 10, which is 2 amps. Now we can take this 2 amps and plug it into both of these right here. So V1 is going to be 2 amps times 2 ohms, which is equal to 4 volts. And the same for this one. V2 is equal to a negative, we keep the negative, 2 amps times 8 ohms. 2 times 8 is 16, so V2 is equal to a negative 16 volts. There you go. Kirchhoff's voltage law.